Hi everyone. Today I want to show you the most intuitive metric to evaluate machine learning models. And not only machine learning, but you can evaluate any type of models, yes, even created manually, yes, by if-else type models, etc. And sometimes that metric, yes, is only one that can be used because sometimes you create models not to classify some items, yes, or some, I don't know, clients or something else. You build the model to sort them, yes. For example, you want to sell something to your customer, yes, and you are building model which are sorting them in they're willing to buy something from you. So when you build model like that, yes, the precision recall and accuracy, yes, is not so important. Yes, the in that case, uplift is more important. So today I show you what is uplift. And I show it on example of German credit data. That's public data set about loans from some German bank, whereas you have information about customers who took loan, and you can try to predict if they default or not. So there is a description, and I better show you how it looks like in Python. I'm using Google Colab here, and I will share that link in description. So the first I at first I download the dataset. I just have a link, and then I do a little bit of renaming, and I change classes from 1 and 2 to 0, 1 because it's easier to work that with classes like that. So look, the data set looks like that. It's variables describing the customer who took loan, and they are coded into some codes. You can look it in the description, yes, but for me it doesn't matter because I would use machine learning model, yes, to build my model automatically, yes, without even understanding the data. You should never do this in real life, you know. At first, you should try to understand your data and build some heuristic model, yes, and then try to build machine learning model that finds dependencies automatically. And classifications here is our target variable, which I will try to predict. I will use CatBoost to predict. I use it because it encodes categorical variables automatically for you. Yes, you don't have to do one hot encoding or something else. It just works out of the box with the data set like that. So let's go from CatBoost import CatBoost classifier. And I think I just don't have CatBoost here, and I should install it first. Pip install. Notice that I started from the exclamation mark. It's how things installed in Google Colab. Pip install CatBoost. By the way, CatBoost is created by Russian company Yandex, and I think CatBoost now is pretty popular in the world of machine learning because it's a very powerful tool, and you don't have and you it works just immediately. You don't have to prepare your data set at all. From catboost, import catboost classifier. Let's just let's just find it from the package. Yes, I just made a typo. Then I create model, and I will use just default parameters. And I also want to have test and train split from learn model. I believe model selection import train test split. And let's prepare immediately the train and test split. And I always forgot the order of the variables here. Train test. Yes. So I would type x train x test, y train, y train, y test equals. And here I pass my data, and I would use that list names just without the last element here, like that. The df names column -1, df -1. And I will set the split itself. Split, where is it? Train size and train size. Test size. I will use test size, and I will make it 30%. Let's look. -1. What? Def. Of course, I should put put names here. Names -1. Yeah. Okay. Next, I will train my model. Model fit, and here is the parameters. I should put x train, y train, and then I would use eval set to prevent my model from overfitting. It's a very nice feature of catboost. Y x test, y test, and let's try and see it can work with categorical feature. Yes, because I should say catboost what categorical features do I have. So to do that, I can do like this: the df and select d types, and I can select objects by select columns by their data type. So look, df d types, and all categorical values here have object, yes, as their data type. So I can select all objects columns like that. Object, and I only need the column names, columns like this, and I can save it to calls. To calls, I usually use name like that. And here I have cat features. Cat features equal calls, and now I think I can start the train. Yeah, look, it's training. Okay, done. And now I want to evaluate my model. So first of all, I create data set with my predicted target. So I do it like this: df equals pd data frame, and then I pass here a dictionary. Y true equals, I will work with a test data set. Y true, it's Y test. Then Y pred. I don't need pred. Yes, I want to, because I want to make a classification report, so I will make just predictions. Model predict, and here is X test. Then I will use Y, I just call it prop. And here I will use model predict proba. X test. And I need the probability of the class class 1, the first class. So I would do it like this. So that gives me the second column of the predict proba method, which is works like predict proba in sklearn. It gives you two columns. First one, the probability of 0 class, and the second one, the probability of 1 class. So, and if you add it together, you will get 1. Okay. The df head perfect. Now I can, at first I will evaluate the model using standard metrics from sklearn metrics import rock aux curve precision recall curve and classification report. So let's start from classification report. What's wrong? Rock au I think just rock curve. Yeah, because AUC is an area under the curve. Under the curve. Start from classification report. Print classification report, and here I should pass the FY true and df Y pred. Boom. I have some metrics here, yes, and I could see that the first class, yes, the main reason that I want to predict it, yes. By the way, what's if I just find the what the fraction of the first class do I have here? Yes, PD, MP, NP mean, and Y test. So I have about 30% of default in that data set. Yes, so the classes are slightly unbalanced. Okay, and I see that precision and recall and F1 score is pretty low. It's not very good model, but That's a very good case for showing your the uplift metric and how you can evaluate your models using it. So let's plot our curve and rock curve. It takes I just type it y true and df prop, yes, and it returns FPR and TPR and threshold. FPR, false positive rate, true positive rate, and threshold I do not need, so I put it in underscore like this. Okay, and now plot. I use it. I do it like this: PD data frame, just to not import matplotlib and etc. and dictionary. And now I use FPR as FPR, CPR as sorry, TPR. It's TPR. Now set index of FPR and plot. So see, here I have my rock oak curve and rock curve. I'm sorry, and it looks nice, but from a classification report, yes, I could see that it's not very good. And here, yes, it's not the best case to evaluate the model with a rock curve because the classes are unbalanced. Yes, we have unbalance here. So let's look at precision recall curve. So I just precision recall curve. Yeah, it takes same arguments. I just copy them, and it returns precision, recall, and threshold. Boom. And now plotted same way. I just type it PD data frame. Now dict precision recall set index precision. I think it should be recall, yeah. Plot. Yeah, here we have our precision recall, and you see that it looks like the straight line, yes, which is very bad because I want to have my precision high, yes, while I have my recall increased, yes. So it means that when I increase the threshold, yes, I bring down my precision, yes, which means that when I predict the positive class, yes, it usually not positive at all. But so the model is bad actually, yes. And with precision recall chart, you can say it pretty surely. But now I will calculate the lift, the uplift metric, like I like to do it, because it's hard to explain that curves to non-technical people. Yes, so it's very complicated, and if you involve some kind of type 1 or type 2 error, yes, you will have your boss asleep very fast. So you should come with something something intuitive. Now I show you. So I have the F here, yes. So first of all, I will calculate the percentage of the percentile of probability. So, and look, probability head. I want to look at first at distribution. Yes. So see, it's highly skewed. So I just should keep it in mind when calculate that metric. So I will do it like that. Probability PCT. It's just for percentile, and I do it like that. Prob rank. That's my favorite function in pandas. True, and I want to find, for example, if I take a top five customers by their score, how many default customers will I find? So I want to have here the percentile here in descending order. Ascending equals false. Like this, yeah. Okay, so let's look. For example, yes, what does mean this number? Yes, means that 40% of that sample have the score higher than 34 percent, or just fraction of 44. Let's check it. df prop more or equal that, and I will take len and to calculate that percentage. See, it's 40%. So the otherwise it should be 60, of course. Yeah, and I will round it here because I want to. I don't want that that precision here. I want to have to just for two signs like this. Okay, and now I will create the table. So it will be like this: df group by prob pct. Then I want to take y true, and I want also have the probability cutoff. So I need a prop here. Prop. You will see why I want to have it. And now I will calculate the sum. Yes, and the mean, because I want the minimal probability for the threshold here for this percentage. Let's check. Yeah, okay. So see, yes, for example, 4% of my sample have scored higher than this number. Let's check it out if it's correct. Oh, so, sorry for that arrow. Yes, that's 4%. Yeah, so that's true. Let's call that data frame lift, and I also like to reset index lift. And you know, I don't like that multi-index here. So usually I just reset it like this: columns equal, and there I will type it prob pct y true prob sum and prob min. Okay. Oh, I just missed some column, I believe. Cut plus lift. What have I missed? Sum. Y true and y min, like this. Okay. Now, now I want to calculate the percentage of the positive class here. So how can I do it? First of all, I should calculate a cumulative sum to the end of that table. See, y true cum equals lift y true cum sum lift head. And it's just the running total. And now I want to have a percentage, the fraction. And y true PCT, I just call it like this. And here I will do like this. See, I will take the previous column and divide it by the total of the column, like this. And now lift. And now I can see something. For example, I will show you lift, and I will take only some values here to be more lift prop, to be more informative, is in, and I will take first 5% of the sample, 10, 2, I will take 15 because it's here is you can have you can find something 4 and 50, and you don't need more, you know. Prop PCT, of course. And see, now I can show you what it tells you. For example, if I take the top 5 people, the top 5 customers by that score in the population, in the sample, which is on that cutoff is on 81. Yes, the score on 81 from the model. I will immediately find the 16% of all bad customers in that sample. So that's what is Uplift all about. And let's calculate the uplift metric. I do it like this: uplift equals lift, and I will y true PCT divided by lift probe PCT. See, yes. So on the first 5%, I have pretty high uplift. So it is 3 times better than just taking customers on a random in a random manner. So then it of course goes down, yes. But now you can see that, for example, if I put the cutoff on 57 on 57, I will I will I will find almost 50% of all bad customers. Yes, so the model is working. And this metric, yes, is very important when you are building sorting models. Yes, because, for example, you have a call center, yes, which has a certain capacity, and you want to select a portion of customers which is a response to your offer better than others. So you can build the model like that and then find the cutoff using the uplift table, and you can, for example, and you can see what uplift will you get. So for me, it's a very good metric for evaluate machine learning models, and I use it all the time, and I find it more useful than ROCAUC, precision recall, rock curves, confusion matrix, what else? Classification report, etc. I think that's the most intuitive way to speak about models, about finding customers which are distinct from other customers in some matter. So that's it for today. Have fun.